Buoyancy practice problems. Buoyancy is the upward force in a fluid. So I'm sure you've noticed when you get into a pool or a bathtub, you feel lighter. Or if you're in the pool with a friend and you try and lift them up, it's much easier to lift them when they're in the water than if you are outside of the water. Buoyancy is that upward force in a fluid. In your reading material, it's on a page that looks like this. Again, yours is probably white. Notice, if the buoyant force on an object is greater than the gravitational force that's pulling it down, the object will float. And this makes sense to me because since the buoyant force is the upward force on an object and gravity is pulling something down, if the upward force is greater than the downward force, then up wins and it's going to float. If the buoyant force, though, is less than the gravitational force, then the gravitational force is greater, which is the downward force, and the object will sink. So when you are looking at these problems on your paper, make sure that if it is comparing an upward force to a downward force, that you just look at which one is greater to determine if it floats or sinks. Another thing is you can find how much force is acting on an object by comparing its actual weight to its apparent weight. The apparent weight is how much it looks like it weighs when you put it into a liquid. So if you put, I should say a fluid because this also works in gases. If you put an object onto a spring scale, it pulls a marker down to its weight. So in this case, you've got some sort of a rock here, and it's being pulled down on the spring scale so that you can see that the weight is 2.25 newtons. When I then put this rock into water and have it on the same spring scale, the spring scale only pulls down to 1.8 newtons. So it seems like the rock is lighter. It's not that the rock is actually lighter, it's just that there's an upward force from the water. In order to figure out how much that upward force is, all I have to do is subtract and find the difference between the actual weight of the object and what it looks like the weight is now, because that amount of difference is how much the water is pushing back up on it. So 2.25 newtons minus my 1.8 newtons will give me 0.45 newtons, and that is the buoyant force of the water on the rock. So some of the problems in here are going to just compare the upward and downward forces, and others are going to ask you to subtract the apparent weight from the actual weight of an object to figure out how much force is acting on it. If you have any more questions about this assignment, please come see me.